Settle in and let your breathing slow just a little. Outside this room, you are drifting over the Arabian Sea, where the water looks like dark glass and the wind keeps a soft, patient rhythm. You think you are coming towards something familiar, a normal island, a simple outline on a map. But Socotra appears like a forgotten stone left in the ocean for a very long time, quietly doing its own strange work. Tonight, with the Sleepless Geographer as your tired guide, you will wander inland at an unhurried pace, from pale beaches to dry riverbeds that only wake up for storms, to trees shaped like upside-down umbrellas, saving every drop of water. No rush, just slow landscapes and the calm forces that keep reshaping them. The first thing you notice is that the sea does not introduce Socotra politely. The coastline arrives rough, with blunt edges and pale seams of sand. From above, the beaches look calm, almost decorative, but down at water level, you hear the constant negotiation. Waves testing rock, rock refusing, foam trying again. You drift lower, and the island's outline stops being a map shape. It becomes texture, cliffs that look chipped, headlands that look bruised by wind. Socotra sits off the southeastern edge of Yemen, out where shipping routes pass by without affection. It is part of an archipelago, not a lonely pebble, but it feels solitary anyway. Not because it is small, because it is separate. And separation is not just a feeling. Separation is a biological rule, written slowly with patience, that makes humans look impulsive. When land breaks away, or sea levels rise, or currents decide to isolate you, evolution gets a quiet room. Less traffic, fewer intruders, more time for odd ideas to survive. You think islands are simple, land surrounded by water. But an island is more like a long experiment, with the doors locked. The ingredients are limited. The weather is stubborn. The visitors are rare. So life does what it always does when it has constraints. It improvises. You come in over a stretch of coast that looks almost soft in moonlight. The sand is pale, nearly white in places, like ground down shells and coral turned into powder. You can feel, even from the air, how the wind combs it into subtle ridges. Dunes that form and unform, like the island is breathing in slow motion. Then the land tilts upward, not dramatically, not like a mountain lunging at the sky. It rises the way an old table rises, steady, worn, and sure of itself. A plateau sits back from the shore, higher and drier, holding its distance from the sea. You land not with a cinematic thud, but with a tired little crunch of sand underfoot. And you walk inland because islands always pull you inward. The coast is a boundary, noisy and restless. The interior is where the island keeps its real personality. The air is dry and it carries salt anyway. That is one of Socotra's quiet tricks, being near water without feeling watered. The Arabian Sea sits close, but rainfall does not arrive like a generous neighbor. It arrives like a guest who visits briefly, eats everything, and leaves you with dishes. Monsoon winds matter here, not as a romantic seasonal shift, but as a force that shapes daily survival. For part of the year, the wind can be so persistent that boats do not bother arguing with it. The sea becomes too rough, the air too pushy, the coastline too unforgiving. So, The island keeps to itself, not because it wants to, but because weather enforces distance. And that distance, year after year, century after century, builds a certain kind of strangeness. Socotra has been separated from nearby land for an extremely long time. Long enough that plants and animals had time to become unmistakably local. Not better, not worse. Just committed to their own odd solutions, you walk across ground that feels like it has been sunbaked and then forgotten. The soil is thin in many places, interrupted by pale rock. Some of that rock is limestone, the kind that dissolves slowly in weakly acidic rainwater. It does not look dramatic while it happens. It looks like nothing at all until you notice the caves. Because limestone keeps secrets. It lets water slip into it, seep through cracks, and hollow out rooms in the dark. And here, where water is not constant but occasional, caves become even more valuable. They store coolness. They store shade. Sometimes they store water, hidden in pockets where evaporation cannot steal it easily. But you do not go into a cave yet. You keep walking, because something ahead looks like it does not belong. A silhouette rises on the plateau, branching upward, then outward, like a strange chandelier. A tree that seems to be holding the sky up with many hands. This is where you meet one of Socotra's most famous residents, the dragon blood tree. It does not greet you with softness. It greets you with geometry. You stand beneath it, and the canopy spreads like an upside-down umbrella. Dense at the top, layered, and strangely flat. It is not shaped that way for decoration. It is shaped that way because the island is stingy with water. A wide canopy catches mist. It catches tiny droplets carried on wind, the kind that never become proper rain. It also throws shade onto the trunk and the ground beneath, lowering temperatures just enough to slow evaporation. This is plant thrift, practiced over a long time. A small savings account of moisture collected one quiet day at a time. The leaves sit clustered near the ends of branches, like they know better than to expose too much surface area. Too much exposure means too much water loss. And here, losing water is not a small inconvenience. It is the difference between living through a dry season and becoming a brittle memory. You think of trees as generous things, giving shade, giving oxygen, giving a place for birds to perch. But here, the tree is not giving. It is managing. It is conserving. It is surviving. The name comes from its resin, a deep red sap that can seep out when the bark is cut. Humans, being humans, saw that color and decided it had to be useful. Medicine, dye, varnish, stories. People have harvested it for centuries, turning botany into commerce. Congratulations! You have discovered that even on a remote island, humans still find ways to collect things. But the tree's real value is quieter. It is proof that isolation can sculpt life into forms that feel almost deliberate, not designed by intention, designed by pressure, sunlight, wind, dry air, thin soil, long waits for rain. And Socotra is full of this kind of practical weirdness. Bottle-shaped trunks that store water, shrubs with tough leaves that refuse to wilt, flowers that bloom quickly when conditions allow, then retreat. A landscape that does not waste effort on being lush all year. You keep walking, and the plateau opens into a view that feels like a calm argument between stone and sky. The ground is uneven, textured with broken rock and low plants that sit close to the earth. The horizon looks clean. The air holds a soft haze, not from humidity, but from dust and distance. It is easy to romanticize this. A lost world, an alien garden, a place that should not exist. But the reality is simpler and therefore stranger. This is what happens when a piece of land stays alone too long and keeps living anyway. Isolation works like a slow classroom. Fewer visitors means fewer competitors, fewer predators, sometimes, fewer diseases, sometimes, but also fewer allies, fewer pollinators, fewer chances to recover if something goes wrong. So life becomes specific. Plants and animals fit their niche tightly, like a key cut for one lock. That can be beautiful. It can also be fragile. You look at the dry ground and imagine a sudden change. New grazing animals, new invasive plants, new roads, new development. On a continent, ecosystems have room to shift and spread. On an island, everything is concentrated. If something breaks, there is not always another place to go. But for now, the island holds. The plateau keeps its calm, and the wind continues its soft persistence. You listen, and you realize the most constant sound is not birds, not insects, not waves. It is air moving past stone. The climate here is often described as arid to semi-arid. Those are tidy words for a messy reality. Rain is irregular, and when it comes, it can come suddenly, not a gentle drizzle. A brief, heavy delivery, like the sky remembered an appointment and showed up late. And when the rain finally arrives, the island changes its behavior. Not by turning green everywhere, by waking up its hidden pathways. You start noticing shallow channels in the ground, dry grooves that look like they were carved by something that does not live here anymore. They are not roads, they are not trails. They are the tracks of water that is absent most of the time. These are wadis, dry riverbeds that are patient enough to wait. They look harmless in dry season. You can stroll down them like corridors between rocky walls. But when storms arrive, wadis become fast rivers with no warning, just intention. You walk toward one because humans always follow lines in the landscape. We like routes. We like the feeling that the land has agreed to guide us. The wadi is wide and pale, its stones rounded in places, showing you what moving water can do when it has a rare chance. Rounded stones are proof of past violence. Softened into something you can hold, water tumbles rock against rock, again and again, until sharp corners give up. It is erosion, yes, but it is also negotiation. The river does not destroy stone instantly. It persuades it over time. The wadi walls rise gently, then steepen. You see layers in the rock, different shades, different textures. Each layer is a chapter that took too long to read in one lifetime. Sediments laid down, compacted, lifted, and exposed. The island is not just a surface, it is a stack of histories. Some of Socotra's geology includes limestone plateaus and older basement rocks. The details are complicated, but the feeling is simple. This island has bones, and those bones have been pushed, lifted, and carved for a very long time. You step carefully over stones that shift a little underfoot. Even dry, the wadi feels like it remembers water. In shaded pockets, you find dampness that lingers longer than it should. A thin, dark stain on pale rock, a tiny patch of green holding on. Then, deeper in the channel, you find what you are hoping for, without admitting it. A pool. Not a grand oasis. A small, shaded basin of water, greenish in the low light, reflecting the rock walls like a mirror that has seen too much. The surface is still. It looks almost sleepy. These pools can persist because shade reduces evaporation and because the rock sometimes funnels groundwater into certain spots. When rain comes hard, water rushes through the wadi, filling depressions. Afterward, the flow disappears, but the pockets remain. Little savings accounts again, nature's favorite strategy on Socotra. You kneel beside the pool, and the air feels cooler here. It is subtle but real. Water changes the local climate in miniature. It adds humidity. It dampens dust. It makes the immediate world feel less harsh. And of course, where water lingers, life gathers. Small insects, birds that know the schedule better than you do, plants that cluster near the edges, taking advantage without being greedy. You watch the pool long enough to notice how it is framed. The rock around it is smooth in places, scalloped in others. This is not just a hole filled with water. This is stone shaped by water's repeated visits. Water is a patient sculptor. It does not need to show up daily. It can work in bursts, one storm at a time, then leave and let the sun do the drying. On islands like this, the rhythm is not constant flow. It is arrival and absence. You keep moving, following the wadi as it bends. The walls begin to show small openings, dark mouths in pale rock, caves or the beginnings of caves. Some are shallow overhangs. Some go deeper, swallowing light quickly. You step into one, just far enough that the air changes. The temperature drops a little. The sound of wind softens, replaced by a quieter, closer silence. Stone holds cold the way it holds memory. Inside, you see the slow evidence of limestone doing what limestone does. Tiny ridges, drip lines, smooth curves where water once traveled. If the cave is deep enough, you might find stalactites and stalagmites, mineral shapes built drop by drop, not carved away like a canyon, but constructed patiently from dissolved stone returning to solidity. It is easy to forget in daily life that rock can move, not like an animal, not like a river, but it moves through chemistry, through pressure, through time. A cave is rock in the process of becoming a different kind of rock. You step back out into the wadi light, and the brightness feels blunt for a moment. The island is full of these contrasts: heat and cool, dry and damp, open plateau and hidden hollow. Everything arranged like a simple lesson in adaptation. And the people who have lived here, because yes, people live here, have had to learn these patterns too. Settlements tend to gather where water is more reliable, where the land offers shade, where the soil can be coaxed into supporting crops. Livestock grazing is always a negotiation with the landscape. Goats, especially, are very good at eating the future. That is not a joke, unfortunately. On dry islands, overgrazing can strip vegetation faster than it can recover. When plants disappear, soil loosens. When soil loosens, wind takes it. When wind takes it, the land becomes poorer, and water runs off faster when it finally arrives. Erosion speeds up, not because nature is angry, but because the protective layer is gone. So even here, in this place that feels like a separate planet, the story is still familiar. Life balances. Humans lean on the balance. Sometimes the balance holds. Sometimes it tips, but tonight, you do not need to solve the island. You only need to notice it, to let its slow processes become part of your mental weather. You follow the wadi farther until it widens again, opening onto a flatter stretch of ground. The rock underfoot becomes more broken, more gravelly, like the land has been ground down and sifted. In the distance, you can see higher ground, plateaus and ridges that look worn, not jagged. These are not young mountains. These are old surfaces, edited by wind and occasional rain. Erosion here does not rush. It sands and scrapes. It uses rare storms like punctuation marks, not continuous sentences. It lowers high points slowly, carries fragments downhill, and leaves behind cliffs where the rock resists longer. You pause and look back toward the coast. Though you cannot see the sea from here, you can sense it anyway, as a presence. Salt in the air, wind direction, a faint, distant roar like fabric being shaken, and you realize something that islands teach very well. The sea is not just surrounding the land. The sea is editing it. Every wave is an attempt. Every storm is an argument. Every calm day is just a pause before the next sentence. Still, the interior of Socotra feels like it has its own pace. It is not trying to impress you with constant spectacle. It is content to be strange, quietly, the way a person can be strange without ever raising their voice. You walk again, and the vegetation shifts. More dragon blood trees appear, scattered not in dense forest, but in clusters and solitary silhouettes. Their canopies make islands of shade on the ground, darker circles where dust settles differently. Under them, smaller plants take advantage of the cooler microclimate, like tenants living beneath a careful landlord. You notice how the tree branches fork repeatedly, each fork a decision made long ago. Grow outward to gather light, but not too much leaf area. Grow upward, but not too exposed. Spread wide. Catch mist. Keep the trunk sturdy. Hold on. There is a gentle lesson here, if you want one. Not about inspiration, about constraint. About how survival often looks like repetition, not drama. The same small choices, made consistently, until they become a form. And because you are human, and humans collect meanings the way beaches collect shells, you start to see the island as a metaphor. A place set apart. A place that had time to become itself. A place where oddness is not punished for being odd. But the island does not care about your metaphors. The island is busy with physics. Wind pushes, always. Sun heats the rock by day, then releases it by night. That daily expansion and contraction can fracture stone over long periods, turning cliffs into slopes, grain by grain. Salt, carried on the air, can crystallize in tiny cracks, widening them as the crystals grow. Even without much rain, stone can still be broken down. Slowly, politely, without fanfare, you stop near a boulder and run your fingers along its surface. It feels rough, warm, and slightly powdery. That powder is the beginning of new soil, though it is not generous soil. It is the kind that needs time and organic matter and steady input to become rich. On Socotra, richness is rare and therefore valuable. Some valleys on the island feel surprisingly garden-like, not because someone planted them, but because geography favors them. A valley can trap moisture. It can shelter plants from wind. It can gather sediment washed from higher ground, so you get pockets where life looks more confident, clusters of shrubs, flowers after rains, greener patches near water. You walk through one of these gentler areas, and it feels like stepping into a different mood. Still dry, yes, but less exposed. The air smells faintly of plants warmed by sun, a soft, resinous scent, like a reminder that living things are making chemicals constantly, quietly, just to keep going. And then, as you crest a small rise, the land opens again. You see the plateau stretching out, and beyond it, the suggestion of cliffs where the land drops toward the sea. The island's shape becomes clearer in your mind. Not a smooth hill in the ocean, but a piece of lifted terrain with edges cut by water and wind. It is tempting to think of an island as something that was placed here, dropped into the sea like a stone. But islands are not placed. They are made. Some islands are born from volcanoes, building up layer after layer of lava until they break the surface. Some are pieces of continents that broke away, carried slowly by plate tectonics, like luggage on an airport conveyor belt. Some are coral platforms that grew upward in warm, shallow seas, then were lifted or exposed by changes in sea level. Socotra's story includes continental fragments and uplift, shaped over very long stretches of time. It is not a young volcanic cone. It is older, more complex, more worn, the kind of land that has been above water long enough to develop deep quirks. You take a moment to imagine time here. Not your time, the island's time. You imagine shorelines shifting as sea levels rise and fall during ice ages far away. You imagine storms arriving, carving channels, then leaving the wadis dry again. You imagine plants spreading, adapting, going extinct, returning in new forms. You imagine human arrivals, trade winds, ships passing, resin collected, goats grazing, villages persisting, and through all of it, the rock stays patient. The plateau keeps being a plateau, even as its edges crumble. The cliffs keep meeting the sea, even as waves steal a little more each year. The island keeps being itself, without needing to be understood. And when a place has had this much time to experiment, you start noticing the shapes of life first, especially the trees that look like they arrived from a different planet. Up close, they look less like trees and more like decisions made under pressure, repeated until the decision hardens into a shape. The trunk rises with a kind of stubborn calm, then the branches fork, and fork again until the canopy becomes a tight, flat ceiling. You do not stand under it so much as you stand inside its strategy. The light beneath the canopy is dimmer, cooler, and slightly green. You can feel the sun still working, but slowed down by shade. In the open, heat lands on you like a hand. Here, It lands like a folded cloth. It is easy to assume the umbrella shape is about collecting rain, but rain is unreliable, and the island learned not to depend on promises. What the canopy really wants is mist, a thin, barely there dampness dragged in by wind. The leaves catch droplets, the branches guide them inward, and the trunk keeps them from vanishing too quickly. This is not romance. This is engineering done with wood and patience. And you start noticing that most of the island's plants do this. Not the umbrella exactly, but the same quiet obsession with not losing what you gained. Leaves are small, waxy, leathery, sometimes covered in fine hairs. Those hairs trap a thin layer of air, like insulation, and slow evaporation. Stems swell where water can be stored. Roots spread wide, or drill deep, or do both, depending on the mood of the soil. Congratulations, you have arrived in a place where survival is mostly accounting. Every drop has to be justified. The dragon blood tree has another trick, and it is not the red resin. It is the way it makes a tiny climate under itself. The shade keeps the ground cooler. Cooler ground means less moisture escapes. Less escape means a little more life can afford to gather there. So you look down, and the dirt is different under the tree. It is darker, softer, and held together with bits of leaf litter. That is not much, but on a dry plateau, not much is a fortune. Seedlings and small plants take advantage, clustering near the trunk like they know the rules. And then you notice the gaps. Some dragon blood trees stand alone, far from the next one. There are places where the plateau feels like it should be dotted with them, but is not. The absence is not dramatic, just quiet, like a missing tooth in a smile. There are reasons for that. Young dragon blood trees do not have an easy childhood. Grazing animals like goats will happily chew on new growth. Dry years can stretch too long. So the adults remain, holding their umbrellas, while the next generation struggles to arrive. You move on, letting the shade slip away behind you. The air warms again, and the wind resumes its steady, low conversation with stone. And the strangeness does not stop at the trees. It just changes its costume. You pass plants with swollen bases, like bottles left out in the sun. Desert roses, thick-trunked and careful, storing water the way people store emergency supplies. Their flowers can look too delicate for the landscape, which is an illusion. The softness is temporary, timed to the rare moments when it is safe to spend energy on beauty. You see spiny shrubs that sit low to the ground, compact and defensive. Being low is not laziness here. It is shelter. The wind is harsher higher up, and the sun is more direct. Down close to the ground, temperatures can be slightly less punishing, and moisture can linger in tiny pockets. This is the island's quiet theme. The geography makes the rules, and biology learns to whisper them back. Socotra's isolation is why these plants feel so particular. Long ago, the land here became separated from larger neighbors, and it stayed that way. Not isolated like a cabin in the woods, isolated like a room sealed for ages. Fewer new seeds arriving, fewer new animals arriving, less mixing, more time for odd traits to become normal. In biology, you would call many of these species endemic. That means they live here, and almost nowhere else. Endemic is a tidy scientific word for a messy reality. It means if this place changes too quickly, the species do not simply move next door. There may be no next door. You keep walking, and the plateau rises and falls gently. The ground is scattered with stones like spilled gravel. You can hear your steps crunch, then soften, depending on whether you hit sand or rock, and every so often, you find a place where the land opens into a wider view. A slight overlook where you can see the plateau stretching, with occasional clusters of strange trees. The sky is pale, the kind of pale that comes from dry air and distance. Clouds are thin, and when they appear, they look undecided. When wind pushes over the plateau, it carries tiny grains of dust. Those grains are not dramatic. They do not form a sandstorm every afternoon, but they are persistent, and persistence is how landscapes get rewritten. Dust is a traveler. It lifts from bare soil, from dry riverbeds, from the edges of dunes. It drifts until the wind gets bored and drops it somewhere else. Over time, that dust becomes part of the soil in a new place. A slow redistribution of the island, one invisible grain at a time. You may not notice the dust on your skin right away, but if you run a finger along a rock, you find it. A faint powder, like the island is constantly being sanded down. In some places, the plateau gives way to shallow valleys. These are not green valleys, not the kind that look like comfort. They are simply lower places where water might gather. The plants here seem slightly taller, slightly more confident, not lush, just less tense. And when you step into one of these folds in the terrain, you feel how microclimates work. A few meters lower can mean less wind. Less wind can mean less evaporation. Less evaporation can mean a few more shrubs and maybe a flowering plant after rain. Everything is connected by small advantages. You keep drifting through this living puzzle, and your mind starts asking the obvious question. If the island is dry and the wind is relentless, where does any of this water actually come from? The answer is not one thing. It is several imperfect things working together. Sometimes it is the seasonal shift of monsoon winds pushing moisture into the region. Sometimes it is a storm that forms over the sea and decides, briefly, to be generous. Sometimes it is mist, the kind that never becomes rain, but still provides a slow drink. And sometimes it is water stored in the ground, moving through cracks in rock, emerging in shaded places like a secret. So you follow the land again, because the land is always pointing somewhere. It angles downward toward channels that you can almost miss if you are not paying attention. Dry lines, subtle trenches, the ghosts of rivers that only exist when the sky remembers them. You find another wadi, wider than the last. It feels like a corridor carved through pale rock, with stones scattered like old bones. Here and there, the rock walls show a smoother surface, polished by past floods. Wadis are deceptive, and you can feel why. In dry season, they are inviting. Flat ground, easy walking, a clear direction. In a storm, they become traps. When rain hits hard ground that cannot absorb it quickly, water runs off fast. It concentrates into channels, and the channel becomes a conveyor belt of force. The flood does not rise politely. It arrives like someone throwing a door open. You imagine standing here during one of those rare violent rain events. The sky darkens, the air cools, and then the sound begins. Not gentle rain on leaves, but a hard drumming on stone. Water starts sliding downhill, gathering, finding the wadi like it was designed for it. Within minutes, the dry bed becomes a moving sheet, then a stream, then a roaring, opaque flow carrying sticks, stones, and anything else that failed to get out of the way. The water is brown with sediment because erosion is always happening when water is in a hurry. And then, later, silence again. The flow drains away. The wadi returns to dry stones and sunlight. Only the rearranged gravel tells you it happened. You walk along the wadi now, in its quiet phase. The stones underfoot are rounded, and their rounding is a kind of record. Sharp edges do not survive long in a channel that floods. The flood tumbles stones against each other until they become smooth enough to stop fighting. You find another shaded pocket where the wadi narrows and the walls rise higher. The light is reduced and the air feels less aggressive. Here, you see more green, not a forest, but an honest attempt. A few ferns cling to damp cracks, small shrubs lean toward any hint of moisture, and in a depression in the rock, there is water again. This time the pool is clearer, reflecting the rock ceiling above it. The surface is so still, you can see tiny ripples caused by insects touching down. The pool is not large, and it does not need to be. It is enough to change who visits this place. Birds treat these pools like reliable gossip. They remember where they are, even when the landscape looks uniform to you. Insects gather because insects always gather where there is water. And the plants nearby are slightly greener, slightly less brittle. This is how water becomes a storyteller on Socotra. It does not run constantly, so every place it lingers becomes important. A map made of small, wet dots. You keep moving into deeper shade, where the rock walls begin to show openings again. Not just shallow overhangs, but real cave mouths, darker, cooler, and quietly patient. Limestone makes caves because limestone is willing to dissolve. Rainwater picks up a little carbon dioxide from the air and soil and becomes weakly acidic. Not acid like a dangerous chemical spill, acid like a tired, persistent complaint. Over time, that complaint widens cracks, hollows chambers, and connects underground passages. So you step toward the cave, and as you cross the threshold, the temperature drops. It is not dramatic, but it is immediate. Outside, the air is warm and moving. Inside, the air is still and cool, as if the cave is hoarding comfort. Your footsteps sound different here. They echo lightly, then fade. Sound has edges in a cave. It bounces, then gets absorbed by distance and rough stone. You do not need to go far in. Even a few steps is enough to feel the difference between surface time and underground time. Outside, wind and sun are constantly editing the landscape. Inside, change is slower. Here, water works in secrecy. If you could stay long enough, and if the cave is active enough, you might see mineral deposits built by dripping water. The water dissolves calcium carbonate from the limestone, carries it along, then deposits it when the drip meets open air. A tiny ring of mineral forms. Then another, and after many years, a stalactite grows down like a stone icicle. Underneath, Where drops land, stalagmites can grow upward. Sometimes they meet and become a column, connecting ceiling to floor, a small architectural project funded by gravity and time. And caves can hold other things too: cool air, moisture, and traces of humans who use them for shelter, storage, or simple escape from heat. You step back out, and the daylight feels almost loud. The wadi resumes its dry, open quiet. But now, you carry the cave's coolness in your imagination, like a small piece of shade you can keep. You continue downstream, and you notice how the wadi slowly widens. Sediment spreads out, and the ground becomes a mix of sand and gravel. This is where floods lose energy and drop what they carried. That dropped material can become soil eventually. It is not good soil yet, but it is finer than bedrock, and it can hold water slightly better. So you see more plants here, more scattered greenery, following the logic of deposition. This is the island's inland hydrology in its simplest form: rare rain, fast runoff, temporary rivers, hidden storage, a system built around scarcity. And humans, predictably, try to live inside that system without being erased by it. Settlements tend to appear where water can be found more reliably, near springs where groundwater emerges, near wadis where floodwater can be diverted carefully, in places where shade and wind protection reduce the daily cost of being alive. People here have long used techniques that match the landscape's tempo, collecting rainwater when it comes, storing it, rationing it, growing crops where the soil can be persuaded, moving animals between grazing areas, because leaving them in one place too long turns plants into dust. And goats? Yes, goats remain a recurring character in dry island stories. They are efficient, stubborn, and enthusiastic. They will eat leaves, shoots, bark, and anything that resembles hope. On an island with many endemic plants, heavy grazing pressure can be a disaster that happens slowly enough to seem normal. So, the landscape becomes a negotiation between needs. Water needs to be shared between people, animals, and plants. Vegetation needs to survive long enough to protect soil. Soil needs to stay put long enough to develop. And the wind, the sun, and the occasional flood do not care about any of these negotiations. They just keep doing their work. You leave the wadi behind, climbing back toward higher ground. The plateau returns, open and sunlit, with wind moving across it like an invisible broom. From here, you can start to sense the island's structure more clearly. The high interior, the sloping edges, and the sudden drop to the sea. Socotra is not a smooth mound. It is a piece of terrain with a backbone, lifted and worn down over a long time. And now, with your feet on the higher surface again, you can feel the island's bones more than its skin. The ground under you is a mix of rock types, but the overall feeling is consistent. This land has been pushed up, exposed, and weathered for ages. It has been carved by water when water is available, and scoured by wind when water is not. You walk along a gentle rise, and then the land breaks more sharply. Ahead, the plateau edge begins to form cliffs. You approach carefully, because cliffs always change the scale of your thoughts. You can walk for hours on a plateau and feel like the world is simple. Then you reach an edge, and the island reminds you that gravity is always in charge. The cliff face drops down in pale layers, and you can see where different beds of rock resist erosion differently. Harder layers form ledges. Softer layers retreat, undercut, and crumble. This is differential erosion, which is a technical term for something very easy to understand. Some rocks are tougher, so they get to be scenery longer. Below, the land slopes toward the coast in broken steps. You can see channels cut by past storms, faint lines running downhill. In a few places, you can see fans of sediment where water once spread out, losing energy as it reached flatter ground. Farther out, you can hear the sea again. Not loud yet, but present, like a distant appliance humming in another room. Cliffs on an island are not just dramatic edges. They are the front line of an argument. Wave energy arrives constantly, and it focuses at the base of the rock. The waves exploit weaknesses, cracks, and softer layers. Salt water seeps in, and when it evaporates, salt crystals grow in tiny spaces, prying rock apart grain by grain. So the cliff is always retreating. Not fast enough for you to watch it happen in real time, unless a chunk collapses. But it is retreating. It is stepping backward, slowly, into the island. That retreat feeds the beaches. When rock breaks down, fragments get carried away. Some settle as gravel, some get ground into sand, and that sand becomes the pale seams you saw from above. You stand at the edge long enough to notice small debris at the base, a talus slope of broken rock, the cliff's discarded skin. Every piece down there is proof of earlier failure. A crack widened, a ledge gave way, a storm did what storms do. Congratulations, you are witnessing a process that will not stop. The island is not being preserved, it is being consumed, slowly, by water and air. The strange comfort is that the island does not mind. It has been losing material for longer than humans have had language for it. It will keep losing material after your maps have changed names and borders. You turn away from the edge and walk along the plateau's rim, following it like a line drawn by geology. The wind is stronger here, unobstructed, and it presses against you steadily. You can feel how wind works differently than water. Water chooses channels, concentrates, and attacks with bursts of force. Wind is less focused, more persistent, and more selective. It picks up what is loose. It polishes what is exposed. It carries away fine particles and leaves behind larger stones, like a slow sorting machine. In some places, the ground becomes a kind of natural pavement, a scattering of larger rocks left behind because the smaller dust and sand were removed. This is desert pavement, and it forms when the wind has had enough time to tidy. On Socotra, with its dry air and open surfaces, you can find hints of this. Not a perfect textbook example, but the same idea. The landscape is being sifted, and then there is the sun doing its daily work on stone. In the heat of day, rock expands slightly. At night, it cools and contracts. Over and over, that movement creates stress. Tiny cracks grow, edges flake. This is thermal weathering, and it is boring in the best way. No drama, just repetition. Add salt to the mix, carried inland by sea air, and the cracking can speed up. Salt crystals grow in pores. Pushing outward, the rock becomes weaker, and then wind and gravity finish the job. So when you look at a broken slope, you are seeing many forces cooperating. Not consciously, of course, but effectively. You keep walking, and the plateau begins to soften into rolling higher ground. The land feels less like an edge and more like a worn surface that has been sanded down. This is where you start to understand something important about scenery. The view you admire is a paused moment in a process. A cliff is not a place, it is an event stretched across time. A plateau is not stable, it is just slow to change. And because the change is slow, your mind can rest in it. You do not have to track every detail. You can let the wind and the stone handle their long argument. As you move, you notice occasional narrow gullies, small cuts in the surface where water once ran in a hurry. These cuts are not permanent rivers, but they are reminders. Even rare rain can shape rock if it shows up intense enough. You imagine a storm again, not because you want one, but because the land makes the storm easy to picture. The sky darkening over the plateau, the first drops hitting dust and turning it into a smell. Then the real rain arriving, hitting rock hard enough to bounce. Water rushing into every low spot, gathering, finding the quickest route downhill. And when it is over, the gullies deepen slightly. The wadi floor rearranges. The sediment fans grow a little wider. Then the heat returns, and everything dries, and the island resumes its patient waiting. This is not a place of constant weather. It is a place of punctuated weather. Long quiet, then brief intensity. You can feel why plants here are built for long pauses, why animals here are built for conserving energy, why humans here have always had to plan for uncertainty. And while you are walking, you begin to notice how the island's high ground affects the air itself. When wind hits elevated terrain, it is forced upward. Rising air cools, and cooling air can release moisture, not always enough to make rain, but sometimes enough to make mist. So the high plateau is not just a dry table of stone. It is also a tool for catching what the atmosphere is willing to give. In some seasons, clouds can brush the higher areas, and the dragon blood trees and other vegetation intercept that moisture. This is sometimes called cloud forest behavior in other places, but here it is more subtle. Not a dripping jungle, just a quiet, frequent dampness. You stand still for a moment and listen. The wind moves through branches overhead, and the sound is soft, like a broom over rough ground. Somewhere far away, a bird calls briefly, then stops. The island does not waste noise. You continue, and the plateau begins to slope more decisively toward the sea. The land is guiding you back to the edge again, because islands always do. No matter how far inland you go, the ocean is waiting to be heard again. As you descend, the rock changes texture underfoot. More loose material appears, more sand mixed into the gravel. Plants shift too, becoming slightly different in density and type, responding to subtle changes in exposure and soil. You begin to smell salt more strongly. The air becomes a little heavier with it, even though humidity remains low. Salt has a way of announcing the ocean's closeness. And then, between low rises, you see it, a pale stretch ahead, bright against darker rock. Sand, gathered and shaped by the wind, lying along the shore like a quiet statement. From a distance, it looks calm, even delicate. But you know what it really is. It is ground down history. Rock reduced to grains, shells reduced to powder, coral reduced to fragments. A whole landscape slowly chewed into softness. You walk toward it, and the sound of your steps changes again. Stone crunch becomes sand hush. The surface gives slightly under your weight, rearranging itself around your foot. Sand is never fixed. It is always negotiating with every step, every gust, every wave. The beach stretches longer than you expected. It is not a small cove, but a broad, pale band, curving with the coastline. In the right light, it can look almost luminous, as if the island is trying to appear innocent. But beaches are not restful places. They are boundaries under constant revision. The wind here is stronger, and it has more material to work with. It lifts fine grains and pushes them inland in thin sheets. Where the wind slows, the grains settle. Where it speeds up, it strips the surface again. Over time, dunes form. Not all at once, and not with urgency. They begin as small ripples, like wrinkles in fabric. Then those ripples grow, and their slopes become more distinct. A dune has a gentle windward side and a steeper leeward slip face, where sand falls and avalanches in tiny slides. You stand near the beginning of one of these dunes, and you can read the wind's direction like handwriting. The ridges align, the slopes angle, and the finer grains collect in certain places. Dunes migrate. They do not sprint. They creep. The wind pushes grains up the gentle side, then gravity drops them down the steep side. Over and over, the dune moves inland like a slow animal. And what is patient enough to live next to a migrating dune? Mostly plants that can tolerate burial, or plants that can anchor sand with roots. You see sparse tufts of grass in some places, and low shrubs that hold on, their roots acting like stitches in loose fabric. Coastal shaping is a three-way negotiation here. Waves deliver energy, wind moves material, and the shape of the land decides where that material can rest. You walk closer to the waterline, where the sand is darker and firmer from moisture. The waves slide in, thin and foamy, then retreat, pulling grains with them. That back and forth movement sorts the sand by size. Finer grains can be carried farther. Coarser grains settle sooner. If you look closely, you can sometimes see bands of different texture. A slightly darker strip, heavier minerals left behind, a lighter strip, finer material redistributed. The beach is a sorting machine, and it never shuts off. The sound here is steady, repetitive, not exciting, just relentless. The sea does not need variety. It needs time. And salt is everywhere. It is in the air, in the spray, on the surface of rocks. It coats things lightly, then disappears. Then, salt can corrode metal quickly, which is one of the reasons coastal life has a constant maintenance problem. Everything rusts, everything weathers, everything needs attention. On stone, salt does a quieter kind of damage. It seeps into pores and cracks, then crystallizes as water evaporates. Those crystals expand, pushing grains apart. This is one of the ways cliffs weaken, and why coastal rocks can crumble faster than you expect. You pick up a small stone near the shoreline. It feels smooth, tumbled. Maybe it began as a sharp fragment from a cliff fall. Then waves rolled it back and forth, grinding it against other stones. It lost its corners, like a person losing sharpness after too many years of the same argument. You let it fall back into the sand. Now, as you walk along the coast, you start noticing how irregular the shoreline is. Headlands jut out, then the beach curves inward. This is not random. Headlands tend to be made of tougher rock, resisting erosion. Bays form where rock is softer or more fractured, allowing waves to carve more easily. Wave energy focuses on the protruding points. It wraps around them, hits them harder. So over long time, even headlands retreat. But they retreat slower, and their stubbornness shapes the whole coastline. You pass a section where the cliffs are closer to the sea, with less beach in between. Here, the waves have less room to spread out, and you can hear the impact more clearly. The water hits rock with a dull thump, then the sound of foam collapsing. This is hydraulic action, which is a technical term for waves punching air into cracks. When waves force air into a fracture, pressure builds. Over time, that pressure helps widen the crack. It is not dramatic on a single day. It is dramatic over thousands of days. You keep walking until the sand becomes finer again and the beach widens. The wind brings a faint hiss as it skims over the dune ridges. It is a soft sound, but it carries far because there are no trees tall enough here to block it. You look inland and you can see how the dunes creep toward the plateau's lower slopes. The island is being dusted with its own broken edges, and still life persists. Small plants hug the ground. Insects move quickly, efficient, and unsentimental. Birds travel along the shore, scanning for anything edible. The coastline is not empty. It is simply minimal. And after listening to the sea for a while, your thoughts begin to drift outward. Because islands do that to you. They make you aware of distance. You start thinking about other isolated coasts, other pieces of land surrounded by water, each with its own rules. Some islands were born hot, built from lava and ash. Some were born quiet, lifted from coral reefs like skeletons raised from the sea. Some are fragments of continents that broke away and spent millions of years becoming strange. So, without rushing, your imagination loosens its grip on Socotra's shoreline. You let the sound of the waves become a bridge, carrying you across dark water to other remote places, other islands that feel like separate planets, waiting under different skies. The water beneath you darkens, and the island behind you becomes a low shadow, then a memory. Out here, distance is not measured in miles. It is measured in how quickly the last shoreline disappears. You drift toward another kind of isolation now, the kind that begins with heat. An island that started as a wound in the ocean floor, leaking molten rock until it built a place to stand. You think a volcanic island is finished once it breaks the surface? Wrong. That is just the beginning of its long cooling problem. At first, it is raw basalt, black and sharp, still holding the mood of fire. Lava cools fast when it meets seawater, and the rock can fracture like broken glass. Wave after wave hits it, not gently, but with the impatience of physics. The new island steams and hisses and pretends it is stable, but it is still settling, still cracking, still shrinking as it cools. You can hear it sometimes, faint pops, small collapses, little internal arguments. And then comes the slow humiliation of fresh rock. Because rock, fresh from the mantle, has no soil. It has no nutrients in a usable form, no sponge for water, no soft layer for roots. So life arrives the way it always arrives, as a nuisance, a film of bacteria first, then algae, then lichens that look like stains. Lichens are part fungus and part algae, a little partnership built for misery. They secrete weak acids and pry minerals loose, turning solid stone into the beginning of dirt. Congratulations! The first residents are basically living sandpaper. Wind brings dust from faraway continents, dropping it into cracks. Birds arrive, rest, leave droppings, and accidentally contribute fertilizer. Salt spray coats everything, which is not helpful, but it is consistent. After years, then decades, the island starts to hold a thin skin of soil. Not enough for forests yet, just enough for grasses and small, stubborn plants. The geology is still young, but biology is already improvising. You walk inland on this imagined island, and you feel the slope under your feet. Volcanoes build broad mountains, but they do not build them evenly. Lava flows choose paths like spilled syrup, thickening some sides, starving others. You reach a ridge and look down into a valley that used to be a river of lava. Now, it is a channel for rainwater, because landscapes recycle their grooves. If lava once found the easiest route downhill, water will too. And the sea keeps working at the edges, turning collapsed lava into black sand. Black sand beaches look dramatic in photographs. Yes, in person, they look like the planet has been burned and never cleaned up. The sand gets hot quickly because dark grains absorb sunlight efficiently. Walking on it at noon feels like stepping on a baking tray. Even the wind feels warm, as if it passed through an oven. You realize how quickly volcanic islands can make their own weather. High slopes push air upward, and rising air cools. Clouds form where the wind is forced to climb. Then rain falls on one side. So you get a wet side and a dry side, separated by a ridge. One side grows green. The other side grows resentful. Humans build towns on whichever side has fewer problems, which varies by island. On some volcanic islands, the rain is so reliable that rivers cut fast. Basalt can be tough, but it fractures, and fractures give water a starting point. Water exploits those lines, turning cracks into gullies, gullies into canyons. You think volcanic islands are simple cones, but give them time and they become heavily carved sculptures. And then, if you wait long enough, the volcano quiets down. Not forever, just long enough to let everyone relax, which is always a mistake. The island begins to sink slowly under its own weight, not because it is failing, but because the ocean crust beneath it bends like a tired mattress. The hot rock cools and contracts too, lowering the whole structure. Subsidence, a slow downward drift like a ship settling deeper into water. While it sinks, corals may start building a reef around its edges. Corals are tiny animals that build calcium carbonate skeletons, basically living cement. They only work in warm, clear, shallow water, with enough sunlight to feed their algae partners. So on the right island, you get a strange race. The island sinks, the reef grows upward. If the reef grows fast enough, it stays near the surface. This is how you can end up with an atoll, a ring of coral surrounding a lagoon, a circular reef with no volcanic island in the middle anymore. just water, an island that has been replaced by its own shoreline. You float above one in your mind, and it looks like a delicate necklace on dark sea. But close up, it is sharp coral, salt wind, and a constant shortage of fresh water. Atolls are low, which means storms do not have to climb to reach them. Waves can wash straight across during cyclones, dumping salt into the thin freshwater lens. Freshwater on an atoll is often just rainwater seeping into sand, floating above seawater underground. Drink too much, pump too hard, or let the ocean surge in, and the lens turns brackish. You do not have to destroy an atoll loudly. You can ruin it with quiet overuse. And still, people live there anyway, because humans treat coastlines like invitations. They build houses a few steps from the water, then act surprised when water arrives. You let the atoll fade and drift toward a different kind of island, one that feels porous, pale, and hollow. A limestone island does not announce itself with fire. It arrives with softness and a kind of quiet deception. From above, it can look solid enough. Green patches, white cliffs, turquoise shallows. But when you walk on it, the ground feels like it is full of hidden rooms. Limestone is made mostly of calcium carbonate, often from ancient marine organisms. It is sea life turned into rock, compressed over long time, then lifted up. An old ocean floor, rebranded as land. And limestone dissolves in weakly acidic water. Rainwater picks up carbon dioxide from air and soil, becomes slightly acidic, and starts eating the rock. Not quickly, not dramatically, just steadily, like water learning patience. So limestone landscapes develop karst. Karst is the human word for a place where the ground is honeycombed. Sinkholes, caves, underground rivers, disappearing streams. You walk across a limestone plateau, and you keep your steps careful, because the ground can be thin in places, a roof over emptiness. It does not always collapse, but it has the potential, which is its own personality. You see small circular depressions, places where soil collects and plants gather. You see sharp ridges of limestone, etched by rain into rough patterns. In the tropics, these patterns can become knife-like, limestone pinnacles rising like broken teeth. Water falls, and instead of forming a normal surface river, it vanishes into cracks. It travels underground, out of sight, doing its work in the dark, and somewhere else it may reappear as a spring, clear and cold, as if it was never lost. Humans have a complicated relationship with karst. The springs are valuable, the caves are tempting, and the ground is unreliable. Building a road across it can feel like laying asphalt on a sponge. And because the water moves underground, pollution moves underground too. A spilled fuel tank, a leaking septic system, a careless dump site, the contamination can travel fast. Karst does not filter water the way thick soils do. It is a shortcut system. Congratulations, your drinking water has chosen the express route. You think again of Socotra's caves, their cool quiet, their drip-made architecture. Different island, similar lesson. Stone is not always solid in the way you want. And now your mind wanders toward islands that were never meant to be islands at all. Fragments of continents, torn away by plate tectonics, carried into new neighborhoods. A continental fragment island feels older underfoot. The rocks can be metamorphic, twisted by pressure, or granite that cooled slowly deep underground. These islands do not have the fresh simplicity of basalt or the porous tricks of limestone alone. They have complicated bones. They have scars. You walk on one and you see folded layers in cliff faces. Folds are what happen when rock is squeezed slowly, like thick fabric pushed from both ends. The rock bends because deep underground, under heat and pressure, rock behaves less like stone and more like stubborn wax. Those folds later get lifted, exposed, and eroded, becoming ridges and valleys. So the landscape you see is often a map of old stress. On these islands, rivers may have been flowing long before the sea isolated them. When sea levels rise, valleys flood and become fjord-like inlets. When sea levels fall, the coastline shifts outward, exposing new land. You begin to understand a repeating theme. Islands are not static. They are the visible parts of ongoing processes: volcanic construction, coral building, tectonic drifting, erosion, drowning, lifting. And the ocean is the editor-in-chief. It cuts, polishes, undercuts, deposits, and rearranges. You drift again, from island to island, without urgency. The Pacific offers chains of volcanoes aligned like footprints. Hotspots punch through moving plates, creating a line of islands that get older as you move away. You can picture it like a conveyor belt. The mantle plume stays put, more or less. The tectonic plate slides over it. A volcano forms above the plume, grows. Then the plate carries it onward. As it moves away, it stops being fed by magma. It erodes, sinks, grows reefs, becomes an atoll, then becomes a seamount. A life cycle measured in millions of years, ending in quiet submersion. If you could see the ocean floor clearly, you would see those drowned islands, flat-top seamounts called guillots, planed off by waves when they were once near sea level. Now they sit deep, wearing their old shoreline like a haircut. The ocean never forgets where coastlines used to be. It just buries them. And speaking of burial, you drift to colder water where islands feel harsher and the sea has a different temperament. In higher latitudes, islands can be carved by ice. Glaciers move slowly, but with the determination of heavy machinery that never sleeps. They grind valleys into U-shapes. They scrape rock clean. They leave behind bare, polished surfaces. When the ice melts and sea levels rise, the carved valleys flood. You get fjords, long, deep inlets with steep walls, dark water, and a sense of depth that makes your stomach drop. You stand at the edge of one, and the air smells of cold salt and wet stone. The water below is calm on the surface, but it is deep, and it holds old sediment. The walls are so steep that waterfalls can appear to fall straight into the sea. The rock here often shows striations, scratches left by stones, embedded in ice, a record of movement, direction, and pressure. It is like the glacier signed its name across the landscape. Humans look at fjords and call them beautiful. They are, in the way scars can be clean and dramatic, but fjords are also reminders that ice once filled this entire space, a thickness of frozen water heavy enough to press the land down. When that weight disappears, the land can rebound. Isostatic rebound? It sounds like a yoga class, but it is the crust bouncing back slowly. The coastline shifts not only because sea level changes, but because land level changes too. So even after the glacier is gone, it is still changing the map. You let the cold islands fade too, and return to the broad concept that ties them all together. Isolation, yes, but also movement. Because islands can feel like fixed points, but nothing about them is fixed. They are temporary high spots on a restless planet. Some will be eaten by waves, some will drown, some will be lifted, some will be connected to mainlands during low sea levels, then cut off again. And while you drift in this archipelago of thoughts, you start noticing the one thing all islands share. They are surrounded by the same ocean, and that ocean is never still. The water looks calm from a distance, like a sheet of dark glass. But the calm is an illusion, the way a sleeping animal looks peaceful until it moves. Currents flow constantly, carrying heat, salt, and life across entire basins. They are not just surface features, they are the ocean's circulatory system. You can stand on a coast and feel it without seeing it. The water temperature changes unexpectedly. The fog arrives on schedule. The beach shape shifts after a storm and does not fully return. A current is basically a river made of seawater, and it obeys forces that do not care about your plans. Wind pushes water at the surface. Earth's rotation bends moving water, the Coriolis effect, which is a technical term for the planet quietly interfering. Water piles up in some places, drops in others. Differences in temperature and salinity change density, and dense water sinks. This drives deep circulation, the slow overturning that moves water through the abyss. Warm water tends to hold less dissolved gas than cold water. Cold water can sink, carrying oxygen downward. So places where surface water cools and sinks become important for deep ocean life. It is strange to think about. Oxygen delivered to the deep sea by sinking water at high latitudes. Breathing at depth depends on distant cold. You drift above a boundary in the sea where currents meet. The surface can look streaked with lines of foam and drifting debris. These are convergence zones, places where floating material gathers. Seaweed, plastic, wood, anything that floats long enough, it gets collected. Some zones become massive, like slow-moving garbage patches. Not a solid island of trash, more like a soup of fragments spread over wide areas. Congratulations, you have invented a new kind of marine sediment. But the ocean does not only collect, it also distributes relentlessly. Waves are energy traveling through water, and when they reach shallow depths, they transform. They slow, steepen, and break, dumping energy onto the shore. That energy moves sand along coastlines in longshore drift. Waves approach at an angle, push sand up the beach, then gravity pulls it down more directly. The sand zigzags along the shore, one grain at a time, like a crowd shuffling sideways. Over months and years, this builds spits, barrier beaches, and sandbars. It can also starve some beaches and feed others. One town builds a jetty to protect a harbor, and the beach downcurrent starts eroding. Humans call it coastal management. The ocean calls it consequences. You stand on a shoreline after a storm, and you see how quickly the sea can rearrange things. A dune scarp appears where yesterday there was a gentle slope. Seaweed piles in thick lines. Sand is stripped from one section and deposited in another. Then the storm passes, the sea calms, and it looks innocent again. That is one of the ocean's best tricks, doing violence, then returning to a steady rhythm. And beneath the surface, the ocean is still working. It carries sediment off the continental shelf in turbidity currents. These are underwater avalanches, heavy with mud and sand, flowing down submarine canyons. They can snap seafloor cables, the same cables that carry much of the world's internet. So, a landslide you never see can interrupt your videos, your messages, your calm little illusions of control. Underwater, the planet is constantly slumping. When the sediment finally settles in deep basins, it forms layers. Over time, those layers become rock, shale, sandstone, limestone, future cliffs made from old seafloor deposits. So the ocean is not only shaping coasts, it is building the material for future continents. Slowly, quietly, with endless repetition. You can feel soothed by that repetition if you let yourself. The waves are never finished, and that is their comfort. They do not need progress. They just need motion. And the motion is not only horizontal. In some places, deep cold water rises to the surface, bringing nutrients up, upwelling zones, where winds push surface water away from coastlines, and deeper water replaces it. These areas can become rich fishing grounds because nutrients feed plankton, plankton feed fish, fish feed everything else. So a sleepy coastline can hide a very busy ocean beneath it. But there is a twist that always feels unfair. Some upwelling zones also keep coastlines dry. Cold upwelled water cools the air above it, and cool air holds less moisture. It can create stable layers of air that resist rising, resist cloud building, resist rain. You get fog, yes, but not generous rainfall. So you can have a desert next to an ocean because the ocean is too cold to help. It is like standing beside a full glass of water you are not allowed to drink. And now your drifting mind begins to aim toward land again, not island land this time. A coastline with dunes and salt flats, and behind it, bright stone, dry air, and a desert that should not be here. You stand at the edge of such a place, and you feel the contradiction immediately. Salt on the breeze, and yet your lips dry out anyway. Waves in front of you, and dust behind you. You think proximity to the sea guarantees humidity and rain. But the atmosphere does not work on fairness. It works on circulation. In places like the Namib Desert along southwestern Africa, or the Atacama along western South America, the ocean is right there. And still, the land is almost empty of rain. Cold currents run along these coasts. The Benguela Current in the Atlantic, the Humboldt Current in the Pacific. They bring cool water from higher latitudes, and they cool the air above. Cool air stays low. It forms a marine layer, often foggy, often gray, and stubbornly stable. Stable air does not rise easily, and rising air is what makes rain clouds. So the coast gets mist and fog, but the interior gets dryness. Sometimes, the fog is the only regular water source, and life treats it like a scheduled delivery. You walk inland from the beach, and the sand becomes drier, looser, and more willing to move. Dunes rise, tall and clean, their edges sharp in the low sun. The wind here has a particular sound, a steady hiss over grains. In some deserts, sand can even sing. Certain grain sizes, certain dryness, certain slopes, and the dune can produce a low hum during a sandslide. It is not magic. It is physics and friction, but it feels like the desert clearing its throat. You climb a dune slowly, and the sand gives way under each step. You gain a meter, lose half a meter, repeat. Deserts teach you efficiency by making effort expensive. At the crest, the view is deceptively soft. Dunes look like blankets draped over the earth, but each dune is a record of wind direction, wind strength, and time. Some dunes are barchans, crescent shapes with horns pointing downwind. These form where sand supply is limited, and wind is fairly consistent. Other dunes form long ridges, aligned with prevailing winds, like fingerprints across the land. And between dunes, you find gravel plains, hard surfaces where fine material has been blown away. This is deflation. Not emotional deflation, but wind removing loose particles until only heavier stones remain. You walk across that stony surface, and it crunches like broken ceramic. The sun reflects off pale rocks, and the heat rises in shimmering layers. Even your shadow looks thin. The stone here breaks down in its own slow ways. Hot days, cool nights, repeated stress. Tiny cracks widen, grains loosen, and fragments fall away. This is mechanical weathering, the rock being pulled apart without needing much water. In some deserts, salts do a lot of the work too. Salt crystals grow in pores, expand and fracture the rock from inside. You find a boulder with a flaking surface, thin sheets peeling off like old paint. Exfoliation, a slow skin shedding of stone, sometimes driven by temperature changes, sometimes by salt. It is not fast, but it is constant. Desert landscapes can look unchanged because the changes are small and spread out, but the rock is always becoming something else. And when rain does come, it often comes like an interruption. A sudden storm, hard drops hitting hard ground, water running off immediately. In dry places, soils can develop crusts that repel water at first. So rainfall becomes runoff, and runoff becomes flash floods. The same desert that looks empty can become briefly violent. Water rushes through dry channels, carrying sediment in a thick brown flow. Then it is gone again, leaving behind rearranged stones and fresh-cut edges. You look at a dry wash and you can tell it has flooded. The banks are steep, the channel is braided, the debris lines sit higher than they should. Deserts leave clues, even when they are quiet. In coastal deserts, fog can substitute for rain. You watch it roll in, low and smooth, like the ocean exhaling onto land. Plants and animals adapt to drink from air. In the Namib, beetles climb dunes and face into the fog wind. Moisture condenses on their backs and drips down to their mouths. It is a simple behavior, and it looks almost deliberate. Some plants do the same thing with leaves, shaped to catch condensation. Fog nets, built by humans, imitate that strategy. Vertical meshes that collect droplets, a technology inspired by a desert that refuses to rain properly. You keep walking, and the desert begins to show you its brighter stone. Salt flats appear in low basins, white crusts that crack into polygons. These are evaporite deposits left behind when water arrives, then evaporates, abandoning its dissolved minerals. Salt flats look smooth from far away. Up close, they are rough, crunchy, and blinding in strong sun. The air above them shimmers, and distances feel deceptive. These basins can form where there is internal drainage. Water flows in, but there is no river flowing out to the sea, so the only exit is evaporation, which concentrates salts. In some places, these deposits include not only sodium chloride, but gypsum and other minerals, a chemical record of repeated wet and dry cycles. Humans look at these flats and see resources. Salt, yes, but also lithium in some regions, dissolved in brines beneath crusts. So the quiet basins become sites of extraction, pipes and ponds laid out like strange geometry. Congratulations! Even the emptiest landscapes become industrial when the chemistry is profitable. And still, deserts near the sea keep their strange calm. They do not need to be lush to be active. They are busy at a lower volume. Wind moves dust. Dust travels, dust fertilizes oceans sometimes. Iron-rich dust from continents can feed plankton blooms far away. So the desert can influence the sea, and the sea can influence the desert. A loop, slow and indifferent. You stop at the base of a rocky outcrop, and you rest your hand on the stone. It is warm, dry, and rough, with tiny grains working loose. You imagine the same grains traveling one day, broken from this rock, lifted by wind, carried to the coast, washed into the sea, then maybe settling on the sea floor, becoming sediment again. A grain of sand does not have a home. It has a route, and the route is long enough to make your own life feel like a brief pause. Speaking of pauses, the desert begins to rise, not sharply, but with a steady tilt that changes the air. You feel it first in your breathing. Just a slight difference, a little less density in the air, a little more coolness at night. The wind sounds cleaner too, less muffled by heat shimmer. High ground is coming, a place where the world looks less dramatic and more patterned. You move toward it without hurrying, because climbing is always slower than you expect. The slope leads you away from the sea's immediate influence. Salt fades from the air, replaced by the dry smell of stone and dust. As you gain elevation, vegetation thins further, then changes. In some regions, you might find shrubs adapted to cold nights. In others, you find almost nothing, just rock and sky. The ground becomes more stable underfoot, less loose sand, more exposed bedrock, more gravel that has not moved in a while. And when you finally reach a broad, high surface, it does not feel like a summit. It feels like a table, a plateau, stretched out under a wide sky. The wind-up here is the main sound. It does not roar. It speaks steadily, like static on a radio. It presses against your clothes, your skin, your thoughts. From this height, the land below stops looking like separate features. Dunes become ripples. Dry riverbeds become thin lines. Cliffs become edges on a map. The world starts to look like fabric, patterned by processes you can barely feel. Erosion becomes visible as a texture, not an event. You stand still and you let your mind hover over the idea that none of this is fixed. Not the islands, not the coasts, not the deserts, not the ocean currents. Everything is moving, just at speeds that rarely match your schedule. And that is where the strange comfort lives. The planet does not hurry, and it does not pause for you. It shapes itself at its own pace, and you are simply visiting, briefly, from the inside. The wind keeps going, steady and unbothered. As you look out over distant shorelines, and you start to sense how all coasts, everywhere, are connected by the same patient water. That connection isn't poetic, it is mechanical. A slow handshake between wind, water, and the spinning of the earth. You are standing high enough to feel the air behave differently. Down at the shore, the world is all sound and spray. Up here, the movement is quieter, but it is everywhere. The wind on your face is not just local weather. It is part of a wider pattern. Air trying to even out uneven heating. The tropics get more sun, the poles get less, and the atmosphere does its endless delivery job. And as the wind drags across the ocean, it pulls the surface water too. Not much at once, but enough, and long enough to build broad gyres, the slow spinning systems. You picture them like lazy giant roundabouts. Water curves because the planet rotates beneath it. That turning force, the Coriolis effect, is not a villain, it is a rule, like gravity, just quieter. So surface water gets pushed and bent, and it piles up in the middle of these gyres, not in a dramatic heap, just a slight dome. But the ocean notices slopes, even tiny ones. Water tries to slide downhill, and the Coriolis effect keeps bending it sideways. The result is a steady circular motion, maintained by stubborn physics. And along the edges of these gyres, currents become more focused. That is where you get the famous ones, the fast lanes of the sea. Warm currents can slide poleward, carrying heat like a long conveyor belt. Cold currents can slide equatorward, carrying coolness and fog. And this is why two coasts at the same latitude can feel like different planets. You think coastline climate is decided by how close you are to the equator. Wrong. It is also decided by which direction the ocean water is coming from. Stand by a warm current and the air is more willing to rise. Rising air cools, cooling air condenses, and clouds form more easily. Stand by a cold current and the air stays low and stable. You get fog and dry land and a horizon that looks washed out. So now, as your mind drifts from those coastal deserts again, you start noticing the next part of the argument. Water shapes land. Yes, but water also shapes air, and air shapes where water will fall and where it will refuse. You let that loop turn slowly in your thoughts. Ocean, atmosphere, land, repeat. And then you remember something you were promised by maps, that deserts are supposed to be far from water, that dryness is supposed to happen deep in continents, away from moisture. But you have already seen the trick. You have walked in a place where the ocean breathes fog onto dunes, and still, the soil stays thirsty. So you start traveling along the world's edges in your imagination. Not as a tourist, but as a quiet observer of mismatched neighbors. Sea beside sand, waves beside salt flats, fishing boats beside dust. On one coastline, the fog comes in like a low gray sheet. It creeps over cold water, then slides onto land. It is not generous, it is not romantic. It is practical, tiny droplets suspended in air. If you stand still, you can feel the moisture bead on your skin. Not enough to drink, but enough to prove the air is carrying water. And the plants here do not wait for rain. They lean into fog, the way people lean into a warm vent in winter. Some have leaves shaped to catch droplets. Some have fine hairs that condense water more efficiently. Some simply grow where fog lingers longest, because location is strategy. The desert you are walking through looks empty at first glance. Then you notice it is full of decisions. Stones are scattered across the surface, sorted by wind. Finer dust has been lifted away, leaving heavier fragments behind. In places, the ground is armored by this layer, protected from further deflation. And when you find a dry channel, you can read its past like a brief diary. A steep bank suggests fast flow. A fan of gravel suggests sudden loss of energy. A line of debris caught in shrubs suggests how high a flood once reached. Flash floods here are rude. They do not announce themselves with long buildup. They arrive as a correction. Rain falls hard. The crusted soil sheds water, and everything low becomes a drainage route. The channel fills, and the water carries stones that should be too heavy to move. But water, when concentrated and fast, is stronger than it looks. Then it is gone again, leaving silence and rearranged ground. That is the desert style. Long stillness, brief violence. Long stillness again. Speaking of violence that looks calm, you start thinking about heat itself as a tool, not heat as discomfort, but heat as geology's slow lever. Rock expands in daytime, contracts at night. The cycle is small, but the repetition is relentless. Tiny cracks grow, then grains loosen, then surfaces flake away, and salt joins in, because salt always joins in near the sea. Salt crystals grow in pores, pushing outward. They pry rock apart from the inside, the way ice does in cold places. So even without much rain, the coastline still erodes. The desert still produces sediment. The wind still moves it, and the sea still receives it, whether it asked or not. You picture one grain of sand, freed from a cliff face. It tumbles downhill, maybe in a flood, maybe in a slow creep. It reaches the coast, gets picked up by waves, then dragged along shore. It is rolled, chipped, rounded, sorted, and eventually it settles somewhere it will not stay. Because the ocean floor is not a quiet final resting place either. Out beyond the surf, currents still run. Storm waves still stir the shallow shelf. And when sediment piles on a slope, gravity starts planning. Sometimes it fails suddenly and the slope collapses. An underwater landslide forms, heavy and fast, a turbidity current. It surges down submarine canyons like an avalanche in darkness. It carries sand and mud into the deep basin, then spreads out and slows. As it slows, it drops heavier grains first, then finer ones. Layering forms, a graded bed, a signature that geologists learn to recognize. If you could cut a cliff open millions of years later, you might see those layers. You would be looking at the ocean's old deliveries turned into stone. So the desert beside the sea is not wasted. It is a sediment factory, and the ocean is the shipping department. Humans, of course, set up shop in the middle of all this. Because humans love boundaries. We love coasts, even when coasts are trying to erase themselves. We build ports where sand wants to drift. We dredge channels that want to fill. We lay roads across dunes that want to walk. Then we act personally offended when the landscape does what landscapes do. You can almost hear the conversation. The sea moves sand along shore, and a harbor wall interrupts it. Sand piles up on one side, erosion chews the other side. The response is more walls, more dredging, more trucks moving sand back. A coastal economy powered by denial. And yet, it keeps working for a while. Because denial is a renewable resource. Eventually, you let that coastline blur into the larger pattern again. Because you are not here to solve human planning. You are here to watch the Earth operate at its usual speed. And now, after all the low, flat land and the constant edge of water, it feels natural to go higher. Higher places simplify sound. They remove the wave noise, the insect noise, the human noise. They leave you with wind and the slow feeling of stone. So you keep traveling inland and upward, as if the planet is gently lifting you by the collar. The air cools without asking permission. The sunlight feels sharper, less filtered by moisture. Even smells become minimal, reduced to dust and minerals. At first, you rise through foothills, low ridges, and broken slopes. These are the transition zones, where erosion deposits what mountains have lost, where streams spread into braided channels, then vanish into gravel. But as you continue, the terrain becomes more committed. The slopes get longer, the rock becomes more exposed, vegetation thins, then changes its attitude. Plants up here are less about growth and more about endurance. They hug the ground to avoid wind. They grow slowly because soil is thin and cold nights are common. And you realize, without needing to say it out loud, that high ground makes its own kind of desert. Not always sandy, not always hot, but still defined by scarcity. Scarcity of oxygen, because the air pressure drops. Scarcity of warmth at night. Scarcity of easy movement, because slopes punish you for existing. Congratulations. You have traded thirst for thin air. The first thing you notice is your breathing. It becomes slightly more deliberate, even at rest. Not dramatic, not dangerous, just noticeable. Your body expects a certain density of air, and the plateau is not interested in meeting expectations. But the reward is perspective. From above, landscapes stop being immersive and start being readable. You can see the logic of valleys, the alignment of ridges, the way drainage networks lace across a surface. A river system, seen from high ground, looks like a leaf vein pattern. Tiny tributaries gathering into larger channels, all obeying gravity. The land does not need intelligence to organize itself. It only needs slope. And that is when you begin to see deep time more clearly. Not because time is visible, but because the results of long processes are easier to recognize from a distance. A plateau is not just a high, flat place. It is a statement about uplift and erosion. Sometimes a plateau is built from lava flows, stacked like spilled layers of dark paint. Sometimes it is an old seabed lifted high, sedimentary rock now exposed to air. Sometimes it is a chunk of crust pushed upward by tectonic forces, then planed down slowly by weather. The details vary, but the feeling is consistent. High ground is rarely new. It tends to be either built patiently or worn down patiently, or both. You walk across a surface that feels firm, almost indifferent to your weight. Gravel crunches, then stops. Bedrock appears in broad patches, scraped and weathered, but still present. In places, you find cracks widened into joints. Water once entered them, froze maybe, expanded, pried them open, or roots found them, pushed gently, insisted on space, or heat and cold worked them back and forth until they gave. Every crack is a small failure, and failures add up to landscapes. And if you stay up here long enough, you start noticing how wind behaves differently. On a plateau, there is less shelter, wind accelerates over open ground, then slows behind outcrops. It picks up fine dust and moves it in thin sheets. Sometimes it deposits dust in hollows, building small pockets of soil. These pockets become tiny refuges where plants can afford to exist. A miniature ecosystem built in the lee of a rock. It is strange how often life depends on wind losing interest. You keep moving, and the plateau edges eventually appear again. High ground has boundaries, and boundaries create drama. A cliff line might form where rock type changes, or where uplift raised a block and faults created a steep face. Faults are fractures where the crust has moved. Not a little crack, but a serious tectonic seam. You might not see the fault plane clearly on the surface, but you can see its consequences. A straight escarpment cutting across terrain, a sudden step in elevation, a valley that follows a line too neatly to be coincidence. And if you stand near one of these features, the ground can feel oddly alive in your imagination. Not moving today, not necessarily, but capable. Because faults are not history alone. They are potential. The crust stores stress slowly, like a bent piece of wood held in place. Then, sometimes, it releases an earthquake, brief and sharp, reminding you that solid ground is a temporary agreement. Even on a calm night, even in a quiet place, the planet is still adjusting. Tectonic plates drift like slow shopping carts, colliding and scraping over millions of years. Mountains rise, basins sink, coastlines tilt. You feel small, but in a useful way. Small enough that you do not have to control any of it. On a high plain, you can also feel how water begins. Not as a river, but as a collection. A little snow in winter, maybe. A brief summer storm. Mist caught on sparse vegetation. Water pools in shallow depressions, then finds a weakness, then begins to move. The first movement is often invisible. A thin film sliding over rock, a slow seep into soil. Then, with enough accumulation, a trickle forms. A trickle becomes a thread becomes a channel, and the channel, if it persists, becomes a valley over time. You have seen wadis that wait most of the year. You have seen rivers that run all year and still manage to be destructive. Here, on high ground, you are closer to the beginning of both. You kneel by a shallow runnel, barely damp, and you can imagine it after a storm. Water would gather fast on the hard surface, then concentrate into this line. It would cut a little deeper, carry a little more grit, then vanish again. Erosion does not need permanence. It only needs repetition. And now, because your mind is still carrying the memory of Socotra, you start noticing how islands and highlands rhyme. Both create microclimates. Both trap moisture in certain places and deny it in others. Both force life into specific forms. On Socotra, mist and shade were precious. On a high plateau, shelter from wind and sun is precious. Different constraints, same mood. Even the sound is similar. Wind over rock, steady and unbothered. You walk toward a viewpoint where the land drops away in the far distance. From here, you can see the lower world again, the coast maybe, or a broad plain, depending on where you are in this drifting geography. The shapes look gentler from up here. Dunes become soft stripes. Salt flats become pale patches. Riverbeds become thin branching lines. It is almost calming until you remember what those shapes actually mean. Those dunes are moving. Those flats are chemical leftovers. Those channels are flood routes that can wake up suddenly. The earth looks peaceful when it is far away. Up close, it is always in the middle of doing something. You remain on the high ground, letting that contradiction settle. Because there is no need to pick one truth. A landscape can be soothing and violent, depending on the time scale. On the human scale, the plateau is quiet. On the geological scale, it is a surface being lowered grain by grain. On the tectonic scale, it might be rising, even as erosion lowers it. Uplift and erosion can happen at the same time, like two workers arguing over the same project. Mountains often exist because uplift outpaces erosion. When uplift slows, erosion wins, and peaks round off. That is why older ranges tend to look softer, their sharp edges worn away. But even soft mountains can be dangerous. Steep slopes fail, rockfalls happen, thin air dulls thinking. Cold nights surprise unprepared bodies. Congratulations, the view is lovely, and your survival still depends on details. You sit with that thought, and you notice the sky again. Clouds are thin, stretched, moving fast at this elevation. The air feels clean because there is less moisture to scatter light. At dusk, high ground cools quickly. Heat radiates away into open sky, and the surface temperature drops. This is why deserts can be cold at night, and why plateaus can feel sharp after sunset. A low basin might hold warmth longer. A plateau lets it go, and as the temperature falls, you might feel the wind shift. Downslope flows can form at night, cold air draining into valleys like invisible water. Cold air is heavier, so it slides downhill, pooling in low places. This can create temperature inversions, where the valley is colder than the slope above it, a strange arrangement, but common in calm nights. So a valley can become a cold trap. Frost can form below, while the ridge stays clear. The planet loves these small acts of unfairness. You keep wandering across the high surface, not toward an end, just toward another angle. And you begin to sense how often humans have used plateaus as routes. In some parts of the world, high ground is easier than low ground. Valleys can be tangled with forest, cut with rivers, filled with swamp. A plateau can be open, dry, navigable. But living up here long term is harder. Water is less predictable. Soils are thinner, and weather is more direct. So humans do what humans always do. They visit high ground for movement, for grazing, for views, for fortresses. Then they go back down to where life is easier, unless they cannot. Unless the plateau is the only home available, then they adapt, slowly, stubbornly, like the plants. You imagine small settlements built in sheltered folds, stone walls to break the wind, water storage carefully protected, paths worn into rock by repeated footsteps. And you imagine, too, how quickly a high plain can feel endless. Without tall landmarks, distance is hard to judge. The horizon looks close until you walk toward it and it refuses to arrive. This is one of the quiet psychological effects of open landscapes. They stretch time because movement feels slower. They also shrink you because there is nowhere to hide. And that shrinking can be comforting in a strange way. Your problems have to compete with the scale of the land, and they usually lose. You stop at the edge of a shallow escarpment and look down. Below, you can see the faint glint of water far away. Maybe a river, maybe the ocean again, maybe a salt lake catching the last light. Everything below seems to be doing the same work you have been watching all night. Water moving sediment, wind sorting surfaces, rock breaking down into smaller pieces. The planet is not building a final masterpiece. It is just cycling material through different forms. And now your mind circles back gently to where this all began. An island that felt like a separate world, set in the Arabian Sea. Socotra does not need you to understand it to continue existing. But it rewards understanding anyway, the way a quiet place rewards quiet attention. You remember the dragon blood trees, their flat canopies catching mist. That mist, too, is part of the same atmospheric machinery you are feeling on this plateau. Air moved by pressure differences, moisture carried, then dropped where conditions allow. You remember the wadis, dry most days, dangerous on the wrong day. They are another version of the same rule. Water follows slope, and it does not care whether you are walking in its channel. You remember the caves, cool and still, carved by weakly acidic water over long time. Even scarcity can do geology if it has patience. And you remember the beaches, pale seams of ground-down history. The sea editing the island's edges, always trying to simplify it back into sediment. All of these are connected, not by story, but by process. Heat moves air. Air moves water. Water moves rock. Rock becomes sand. Sand becomes seabed layers. Layers become stone again. It is a loop that makes human timelines feel like a brief flicker. You remain on the high ground a while longer, letting the wind be the only narrator for a few beats, because the wind is honest. It does not explain itself. It just continues. And as you listen, you start to notice how even the wind has weight. Not weight like a solid, but weight like pressure. It pushes against your skin, and it shapes what can grow, and it dries what is exposed. In some places, constant wind sculpts trees into bent forms. Flag trees, branches stretched downwind like the landscape is pointing. In other places, wind abrasion smooths rock surfaces, sand blasting them slowly. Ventifacts form, stones with polished faces and sharp edges, created by wind-driven sand. Nature's version of a slow, permanent sanding machine. You run your fingers along a rock face and imagine it over centuries. Grains, striking, tiny impacts, microscopic chips removed. The rock does not notice individual grains. It only notices the total. So when you look out at the world, again, you can almost see the forces as layers. Wind above, water below, rock underneath, time behind everything, and somewhere below, at the edges, the ocean keeps making its steady sound, not loud enough to reach you clearly, but present in the way salt can be present in air. You let your attention drift down those slopes again, back toward coasts and their endless reshaping. Because even from high ground, you can tell where a shoreline is working hard. A broad river delta spreading into the sea, building new land slowly. A cliff line retreating, feeding beaches, a dune field marching inland. And you start to consider one more quiet truth about these places. Coastlines are not just where land ends. They are where land gets redistributed. The land does not vanish when it erodes. It travels. So as you linger on this plateau, with wind moving steadily past you, the world below continues its unending, gentle demolition. Grains shifting, channels deepening, cliffs shedding pieces, currents carrying fragments away, and you find yourself still in the middle of it, not above it, not separate, just temporarily aware. You turn slightly, as if to keep following the shape of the high ground, letting it lead you toward another long